Hello, my name is Ole M Strohm, and welcome to the presentation for our poster about experimenting with C++ libraries in OpenCL kernel code. The reason we would like to be able to use C++ libraries in C++ for OpenCL is that a lot of the language's features come from the libraries. In fact, about 70% of the specification pertains to the standard library. However, this is not easy because there are a lot of features of C++ that cannot be supported by the OpenCL execution module. An example of this is function pointers, which can cause divergent execution, which heavily limits performance on these devices. And the restriction on function pointers also affects virtual methods. Another issue is that C++ does not have address spaces. However, in C++ for OpenCL, every type is required to have one. So for this exploration we use Lib Cxx because it's open source, easily accessible, and well integrated with Clang, the compiler we use for C++ for OpenCL. Now, many headers in Lib Cxx do require these unsupported features, and so to get more useful data, we first disabled the errors completely for these unsupported features and tried compiling the headers anyway. This forces the compilation to continue even when there are unsupported features elsewhere in the file. And it also means that we can test the compiler on the code in Lib Cxx without making any changes to Lib Cxx itself. Now, doing this did expose some issues in the compiler and gave errors for things like incorrect address spaces. So the issues are that, like I said, C++ does not have address spaces, which means that they all have to be deduced by the compiler. And also, even though we did remove the errors for unsupported features, they still are there and will cause issues when trying to use it in the actual compiler. However, the header with least amount of these unsupported features was type traits, and so we focused on type traits specifically. And this is partly because it's a standalone header-only library with compile time features that are suitable for any execution model. And the fact that they are compile time also means that the unsupported features it uses do disappear after compilation. Type traits is also heavily templated, like most of Lib Cxx, which means that it is a good test of the compiler to see how it deals with heavily templated C++ code. Now, running the compiler without errors on type traits showed that the address spaces are already deduced very well. There were only two small bugs that had to be fixed to get it working fully. But there are also some unsupported features that were still in type traits, and so to deal with those, we added two extensions. So first we fixed the bugs in the address space deduction and sent those up to upstream Clang. And here are the two pull requests that we created. And after that, we added two extensions to upstream Clang as well to allow type traits to utilize the unsupported features because we know that they will disappear at compile time. So once we had type traits from Lib Cxx compiling in Clang without any changes to type traits, we started looking at the Lib Cxx tests for it. Now, these tests are very good, and so they test C type traits functionality on classes with virtual methods and similar. So to be able to run these in C++ for OpenCL, we first had to remove the testing of these unsupported features as well. So this was done through a script, and at the end of the script running, 51% of the test had been stripped of these features. However, this doesn't actually limit the coverage of the test because it only removes things that are unsupported by C++ for OpenCL anyway. So a user of the language could never try and put those things into type traits. Now, after editing the tests through the script, we ran the tests, and in the end, 129 of the tests ran as expected. 126 of them are passing tests, and the other 3 are tests that are supposed to fail. However, there are some tests that didn't run as expected. 8 of them are because they have dependencies on other headers, like vector. However, type trace is currently the only header that compiles in C++ for OpenCL, so these tests could not be run. The other 7 that use C++20 features could not be run because currently C++ for OpenCL targets C++17. And finally, there are 3 tests that test type trace functionality that revolve around function pointers. And so, since C++ for OpenCL can't run the tests with those, they are basically unsupported features completely. So in the end, all the tests that can be feasibly run in C++ for OpenCL do run as expected, which is great news. And here we have a code example that uses type trace in C++ for OpenCL. So first we enable the extensions we added, include type trace, and then disable them again. This means that only type trace is allowed to use these unsupported features. Then we have a heavily templated find minimum function, which uses the type trace functionality extend and remove extent to get the array size and the element that the array holds. And finally, there is a compute kernel function that uses this on a int4 array, which both shows that the type trace functionality does compile, and also that you can use types that are specific to OpenCL. So in conclusion, our evaluation has showed the feasibility of porting Lib Cxx to OpenCL directly without any changes. And also, we've enabled type trace for users of C++ for OpenCL to experiment with from Clang 12. Now there are some future work that can be done. For example, adding OpenCL specific functionality to type trace, such as adding and removing address spaces, as well as detecting whether a type is a vector type or not. Also, evaluating support for C++20 in C++ for OpenCL, and support for other libraries such as iterator and algorithms. Finally, we could productize these C++ libraries for OpenCL, either via Lib Cxx upstream or a new libcl Cxx. Here are the resources we've used, and at the end there is a Godboard link to the code example showing that it does indeed compile with upstream Clang. Do check out our poster, and thank you for listening.